Hello there. Welcome to CXC Math TV. And today we're going to be looking at circles. Specifically, we're going to be looking at area and perimeter of circles. And so, with circles, right, first thing we have to know is the different parts of the circle, right? And so these are the different parts of the circle. Don't want to spend too much time on it. We're supposed to know a chord. Anytime you can connect any 2 points on the circumference of the circle, that line is called the chord, the diameter. That is a special type of chord that passes through the center of the circle, right? And it connects 2 points on the circumference of the circle passing through the center. We know the radius already, we know tangent, we know secant. These are the parts of the circle that we must know, and we've covered the different parts of the circle in the circle theorem video. So if you want to go through circle theorem, check out my circle theorem video. We go in detail there. So we already talked about the radius, right? The radius is any point on the circumference of the circle to its center, right? And so we show the different radii. Now, if the radius is 5, what is the diameter? We should all know the diameter is what? 10, right? So we all know that radius is half of the diameter. And if the diameter is 32 feet, what's the radius? We all know that's just 16 feet. No problem. If the radius shown there is 58 centimeter, then the diameter is just double it. The diameter is double of the radius. So write in the equation, the diameter 2 times the radius. The diameter is 2 times the radius. So if the diameter is 78, the radius is 39. Now, we can rearrange sectors, right? Just like, let's say this is a pizza. You buy a pizza, right? You cut it up into different pieces. Those pieces we call sectors. Sectors constitute of, we realize we have a piece of the arc length there and 2 radii. That's a sector, right? So each slice of pizza is known as a what? A sector. If you rearrange, right, if we just move it out, if we move out each piece of the pizza, right, and display it like this, right, why are we doing that? Consider all of these lengths, right? Right? If you're to add, you know, right, you know the distance around the circle is what? The circumference. That's the name, right? But if you were to just consider all the different lengths and then add them up together, this right here could help you to generate the formula for the circumference of a circle, which is 2 pi r. And the length of half the circle is just pi times r. Don't need to get into that, you just need to know the formula. The length of the circumference of the circle is 2 pi r, right? That's nice, right? And all you need to know is the radius of the circle, and that will be help you to find the circumference of the circle. All right, the area of a circle now, the next thing you need to remember, area of a circle is pi r squared. Now I'm skipping over it and I'm not going through the proof because many of us would have learned these from a long time ago. So in summary, you just need to remember that circumference of a circle is, see it here in summary, it's 2 pi r or pi times d, where d is the diameter, and area of a circle is pi r squared. So we're going to use this to tackle a few questions. First one, shown above is a circle with radius 5 centimeter. Work out the radius. So pause the video and attempt this question. Alright, so as you pause the video and you're going to work out this question, first thing is it just wanted the area mean. So area of a circle, pi r squared. Right? And the radius is 5, so it's pi times 5 squared, which is 25 pi centimeters squared. Now, sometimes you have to give your answer as a decimal. So 25 pi, remember pi is 3.14, so you can work that out in a calculator. So you type 25 times, remember pi is 3.14. When you put that in the calculator, you get your 78.5 centimeters square. Alright, if you wanted the decimal. Next one. It says shown below is the circle with diameter 20. Work out the area and also the circumference. Alright, so this time they want you to also find the perimeter as well. So pause the video and do this one. So as you pause and did this one, first thing we know that, let's do circumference first, right? Circumference we know is 2 pi r, and in that case, the diameter is 20, so the radius is 10. So the circumference is 2 times pi times the radius of 10, and you put that into your calculator. You'd get 20 pi, or you can work out 20 times pi in your calculator, and you get 62.8 centimeters. Notice perimeter distance around just centimeter. For the area now, which is pi r square, that's pi times 10 square. 10 square is 100, so we get 100 pi. Then you can put that into your calculator, 100 pi, and we get 314.2. 314.2 centimeter square. Key thing, centimeter square. So remember your units. Remember with circumference, it's centimeter. With area, it's centimeter square. Nice. What about this question now? Pause the video and attempt this one. It says, shown above is a circular photo surrounded by a frame. Photo has radius 12 and the frame has width 4 centimeter. Work out the area shaded. Pause the video and attempt this question. Alright, let's go. So in this question now, to work out the area shaded, right? The area shaded is just the area of the circular photo, area of the big one minus the area of the small one, right? So it's the area of the circular photo. I'm going to put area of circular photo minus the area of the photo, right? Well, actually, let me rephrase it. It's actually the area of the frame minus the area of the photo. The area of the frame, right? So the area of the frame, first thing we need the radius of the frame. So we know this is the frame. Now realize that the frame, this piece is 12 and this piece is 4. So that means the radius of the frame there must be 16 centimeters. So this is now pi times 16 square minus area of the photo, and the area of the photo is pi times the radius is 12 square. So 16 square is 256 pi minus 12 square is 144 pi. And that gives us the area of the shaded region. Stand for shaded. So the area shaded then is equal to, do our subtraction, that looks like 112 pi, but just for safety, we'll put it in 250 pi minus 144 pi, and we get 112 pi. Then we'll put that into our calculator, and that is 351.9. 351.9 centimeters square. And that would be the area shaded. Too bad, right? Not too bad. Nice. This one now. It says shown below is a garden. The garden is 10 meter long and 6 meter wide. There's a vegetable patch that is 2 meter long and 1.5 meter wide. There's a circular pond that has a radius 2 meters. Calculate the remainder of the garden grass in green. So pause the video and attempt this question. Well, to do this question is pretty straightforward, right? We realize that the garden, right, we need to find the area of the garden first. The area of the garden, remember the garden have the length of 10 and a width of 6. So the area of the garden is 10 times 6, because remember, area of rectangle is length times width, so that's 60 meters square. But then now what's inside the garden? What's inside the garden is this vegetable patch along with a circular pond. So now the area of the vegetable patch is the 2 times 1.5 is 3 meters square. And then the area of the circular pond is, remember, area of a circle is what? Pi r square. So that works out to be pi times the radius is 2, 2 square. 2 square is 4. That's 4 pi meter square. So therefore, we need to find the area of the green grass left. So the area that remain is just the area of the garden minus the area of the vegetable patch plus the area of the circular pond. That is 60 minus, we add 3 plus 4 pi, and we subtract it from 60. Now, you just put that in a calculator, right? You don't have to leave your answer exact, right? You don't have to leave your answer exact. So you're going to put that into your calculator. 60 minus, in bracket, 3 plus 4 pi. We do that and we get 44.4. So we get 44.4 meters square, and that's the area that remains. Nice. Easy, easy, easy. All right, this question here now, it says a circle has circumference 40. And so, right, to do this question, right, a circle, it has the circumference of 40, so to find the area. What do you think we're going to do that? Pause the video and do it for me. As you pause it and do it, I love to give a visual representation of what's happening. So I'm just going to put out a circle, right? So I put out a circle and I'm going to give you what we know about the circle, right? So we don't know the radius of the circle. What we do know is the circumference, which is 40. What do we know? We know that the circumference is equal to 2 pi r. Since the circumference is 2 pi r, we know that 40 equal to 2 pi times the radius. So if we divide both sides by 2 pi, that will give us the radius. So the radius is just 40 divided by 2 pi. And we're going to put that into our calculator. 40 divided by 2. We do that and we get that our radius is let me try that again. 40 divided by 2 times pi. Oh, so my calculator is doing that. 40 divided by, in bracket, 2 pi. There we go. So there we go. My calculator was just giving me a little blemish there. So it's 6.37. That's our radius. 6.37 centimeters. So now the area is just going to be pi r squared. So now we can put in the area is pi times 6.37 squared. Put that in our calculator. This was the radius. We're going to square it. Then we're going to multiply it by pi. We'll put all of that in the calculator. We'll get 127.3 centimeters squared. That's your answer. Nice. Let's continue. More questions, more questions, more questions. A circle has area 64 pi centimeters square. Work out the radius. Pause the video and attempt. Alright, now anytime you're given a circle, right, and they give you the exact area, meaning they leave it in terms of pi, right? Since they leave it in terms of pi, they told us the area is 64 pi. Now remember, area pi r square, pi r square. So that means anytime the area is given in terms of pi, just divide both sides of the equation by pi. Get rid of the pi by dividing both sides of the equation by pi. So 64 is equal to r squared. So r is just the square root of 64, which is 8. Look how that was easy. The radius is just 8 centimeters. That was so fun. Nice, that's the radius. All right. All right, what about this question here? It says a logo is designed that has four pink circles within a white circle. The square has side length 16 centimeters and the area of the logo that is white. Pause the video and attempt this question for me, please. All right, let's go. So as you pause the video, you needed to find the area of the white piece, right? First thing we realize is that the area of the white piece, right? Can't we just find the area of the what we call this, the square, and then we minus the area of the four circles. CIR means circle. So if we find the area of the square and then minus the area of the four circles, wouldn't that give us the white piece? Definitely. But look at this. The area of the square is what? 16 square, right? Length square, that's 256 centimeters square. Then the area of one circle, just one. But these are what kind of circle? These circles are identical. So now, in this case, to find the area of the circle, they didn't give us the radius, right? But no problem. If the whole thing is 16, then halfway is 8. This is 8, and this side is 8. And if halfway is 8, then the radius must be what? 4. Nice. So since the radius is 4, right? This piece is 8 and this piece is 8, and the radius is 4. In that case, now the area of the circle is just, I don't know why it keeps disappearing. Let me use a different color. Right? Yeah. So now the area of one circle then is going to be pi r square. So that is now 4 square is 16. This is 16 pi. Now that's the area of just one circle, but these are all identical circles. So now the area of the four circles, so the four of them now is 4 times 16 pi, which is 16 4 is 64 pi. So now we can go back to the formula and write down the area in white. Now the area that we want, the area in white, is equal to 256 centimeters squared minus 64 pi. And you put that into your calculator. 256 minus 64 times pi. And we get 54.9. That works out to be 54.9 centimeters square. That's it. Nice, 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 nice. Now, sometimes they're going to be given compound shapes, right? So a question like this now, compound shapes. So let's move on to compound shapes. I'm going to move on to also finding area of sectors and segments. Let's go, let's go, let's go. So to find area of compound shape, right? You get the shape. How do you find the area of the shape? Well, first thing you do is maybe find the area of that rectangular piece using length times width or base times height. Then you find the area of the two half circles and add them, right? So area of a semicircle is area of a full circle divided by 2. You do that, find the area of that circle, find the area of the next circle now, and then we add all three areas, right? So that gives us the total area. If you did that, that is absolutely fine. Now, why did I do that? The purpose of me giving you this question was to notice with semicircles, it's obvious to just divide the full area of a circle by 2. No problem. So look at this now. How do you find the area of each of these circles, right? Of the blue piece, right here, so it's only yellow, so we now have nothing to do, right? But the second one now, to find the area of the blue piece, is just half the area of the full circle, right? So it is, notice I put 180 over 360, because that would be the angle from the center down, 180 degrees. Now, if you want to find a quarter of a circle, the blue piece next, what do? A quarter is 1 over 4, but where that quarter come from? The angle is 90 degrees over. Total angles in a circle is 360. Now when the angle is 240, that portion represents how much of the circle? 2/3, don't? But really and truly, how we get 2/3? It's 240 over 360. Ah, follow where we're getting at. This piece now 72 degrees, so to find this portion is what? 72 over 360. 13 degrees, so it's what? 13 over 360. I hope you're following. Why are we doing this? Because now in exam, sometimes they're going to ask you to find area of what we call the sector. What the sector? The sector is any part of the circle or portion of the circle that is surrounded by two radii and an arc length. And an arc length is just a part of the circumference of the circle. This is known as a sector. Now to find area of a sector, I'm going to write down the formula from now. Area of a sector, this is all you need to know. It is theta over 360 times pi r squared. It's theta over 360 times pi r squared, where this angle is going to be theta. Once they give you this angle, you're just going to divide it by 360, then multiply it by pi r squared. That's all. Why do we do that? Think about it. If the area of a full circle is 100, you can quickly tell me that up here so must be 50. It's easy to tell me that. Really and truly what you did was you just said the angle is 180 over 360 times the full area of 100. That's what you actually did, and 180 over 360 is half. Then you get the half times 100. That's how you get the 50. If I ask you to give me what is this portion, you could easily tell me it's quarter of 100. But really and truly what you did was put what? 90 over 360 times the 100. 90 over 360 is what? A quarter times 100. That's how you get the 25. And right here, so you could easily tell me this is 3/4 or 75. Really and truly what you did was you put what? This is 270 degrees over 360 times the full area. That is all I want you to write down. The area of a sector, please remember the formula. The formula is what? Theta over 360 times pi r squared. So if I gave you these ones now, it look a little bit difficult, but it's the same procedure. Find the area, right? It's just 1.1. How did I get this answer? You put what? 1 over 360 times 400. Then when you multiply fractions, you multiply their numerators. So you get 400 over 360 is 1.1. Next one, tell me the answer before you see it pop on the screen. What would you do? Theta 5 over what? 360 times pi r squared. And the area, the pi r squared in this case is 400. So that's 2000 over 360, right? 5.5. Good. Likewise, down here, theta over 360 times pi r squared. The answer will be 44.4. So please remember this formula. I'm begging you, area of a sector, theta over 360 times pi r squared. The next one now is to find the arc length. We're almost through. We are almost through. Arc length. Notice, if the area of the full circle is 80, how we gonna find the area of this small piece? Not area, perimeter. How we gonna find the perimeter of this small piece? This red piece, how you think we can do that? Well, can't we just use the same thing, same approach, and say, why not say 6 over 360 times the circumference? Ah, if we do that, we get 1.3. That gonna give you the answer. Why not do the same down here and say, of course, 40 over 360 times the circumference 80. You notice, by the way, I flip them. Sometimes I flip them for, simplicity, but multiplication is commutative. So if you see I have 5 over 8 times 9, and then you see me write 9 over 8 times 5, it's the same thing because multiplication is commutative. I can do that. Alright, so don't worry about that piece. Alright. Now in this case now, right, that is what we have. This is how we'd find now the length of the arc. So the length of the arc, this piece in green is the arc you're seeing right here. The length of the arc, you just need to remember one simple formula. Length of the arc is what? Theta over 360 times 2 pi r. Please remember them. So this is arc length, theta over 360 times 2 pi r. Now we're going to look at some questions that you'd get typically in exams. In exams now, it seems like the question them just get taken to another level. But don't worry. It's okay. Every little thing, it's going to be alright if you remember the formulas. So let's go ahead and do these questions. So we've gotten to these questions, right? We've gotten to these questions. This one says, the diagram shows a sector of circle, center O, with adjoining square. The radius of the circle is 10. Find the area of the shape and the perimeter of the shape. By the way, they told us that the angle is 60. So this shouldn't be 40, this is 60. It's a mistake on the diagram. It should be 60. Now it says find the area of the shape. OACMN. Find the area of the shape. So the area of that shape is just the area of the sector plus the area of the square. We can all agree to that. But how do we find area of sector again? I just told us we have to know it. Area of a sector, the formula they told us was theta over 360 times pi r squared. Theta over 360 times pi r squared. So it's going to be 60 degrees over 360 times pi r squared. Pi times the radius, which is 10 square. That's the area of the sector. Plus the area of the square is what? Length square. So now we just work this out. 60 over 360 is 1 over 6 times 10 square is 100 times pi plus 10 square is 100. Now we'll put all of that in our calculator. So now we'll put in 1 over 2 times 100 pi plus 100. Put everything in the calculator and you get 257.08. The area is just 257.08 centimeters square. That is the answer. It is not difficult at all. Nice. Now it says find the perimeter. This is where it gets really challenging. How do you find perimeter of a shape? To find perimeter of shape, you need to add all the distance around. Isn't that so? So you need to find what? The arc length AC. Then you need to add it to the radius here. You need to add this side, and this side. So we need to add all of those distances to get the perimeter. So the perimeter is equal to OA plus ON plus NM plus MC plus finally we need the arc length AC. Now everyone's okay with adding those sides 10, 10, 10, and 10. So 1, 2, 3, 4. So that is 10 plus 10 plus 10. Why the zeros keep disappearing, I have no idea. Plus 10 plus the arc length. Now here's where the trouble starts. How do you find arc length in a sector? Guys, we just looked at this formula. We just looked at this formula and the formula we said for arc length was what? See it here guys, the formula is there, just remember it. Arc length is what? Theta over 360 times 2 pi r. So the arc length AC is the 60 over 360 times 2 pi r. That's the arc length AC. Please remember it. So in this case, the 60 over 360 times 2 pi r is 1 over 6 times 2 times the radius. 2 times the radius is 10 times pi. And 2 times 10 is 20. So that is now 20. And 1 over 6 times 20 is 20 over 6 pi. So that is it. This is now 20 over 6 times pi. That's it, guys. Now you put all of that in your calculator, please. Stop disappearing zero. All of this in our calculator, 40, because 10 plus 10 plus 10 plus 10 is 40, plus 20 pi over 6. Put that in our calculator, we get 50.5. So all of this works out to be 50.5 centimeters. This is not bad. Nice. So now, pause the video and do this question for me. It says the diagram below shows a sector cut from A, circle of center O, and the angle is 30 degrees. And it says the perimeter is that. What is the area? This is going to be nice. So pause the video and do this question. They give you the perimeter of the sector and they ask you for its area. Pause the video and attempt. Okay, let's go. So now to do this question, since they give us the perimeter, what do we know? What we do know is that perimeter of a sector, right? The perimeter of a sector would be what? We need to add this side, and add the arc length. That's what perimeter is. So the perimeter of a sector is equal to 2 of the radius. So I have to say 2 times the radius plus the arc length. I like to call this side my arc length L. Now they told us the perimeter is 265 over 21. The radius, we don't know. So we have 2r plus the arc length. Now, how do we go about finding the arc length? No problem. What we do know is that the arc length, remember, arc length is what? Theta over 360 times 2 pi r. That's arc length, right? Theta over 360 times 2 pi r. So theta is 30. So that's 30 over 360 times 2 pi r. This is what we do know, alright? So notice in this equation there's only one unknown. And the unknown is what? R. So we need to go ahead and solve this equation for R first. So we go ahead and we do that. First thing I'm going to do is work out 30 over 360. And then that result, the 1 over 12, we need to multiply it by 2 pi, right? We need to multiply it by 2 pi. And so we get 1 over 6 pi, or some people might say we get 0.52. So in that case, notice we get 2r plus 0.52r, and that's equal to the 265 over 21. Now add them, this becomes 2.52r is equal to 265 over 21, right? So finally now we're able to divide both sides by 2.52. And by dividing both sides by 2.52, we're able to find what? The radius. Wow! So we did all of that to find the radius first. So now let's do our division. So 265 over 21 divided by 2.52. We did our division and we get 5 flat. So in that case, we get 5 flat. So our radius is 5 centimeters. Now, once we get our radius being 5 centimeters, now we can find the area. So now we can give them the answer now and tell them. Let me just erase off this now. I need some space. So guys, the formulas are so important to remember. It's easy to follow, but difficult. Trust me, when you're doing it on your own, you might be wondering, how am I going to do this question? But it's not hard. You just have to remember the two formulas. So in this case now, the area of a sector now you have to remember it's theta over 360 times now pi r squared. So now theta is 30 over 360 times pi times the radius 5 square. You just put that in your calculator. It's so easy. 30 over 360 multiplied by pi r squared. Pi times 5 squared. Bam! We'll put that in our calculator and the final answer is 6.54 centimeters. So we'll put all of that and we get area had worked out to be 6.54 centimeters squared. That's our answer. The area is 6.54 centimeters squared. That's it. Easy, 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 easy. Nice. That's it. Too easy. Okay, this question. I want you to go ahead, pause the video, and attempt this question. Go ahead, pause the video and attempt this one. So it says the following diagram, it shows us what? It shows us two sectors. Find the area shaded. It's very easy. The area shaded is just going to be equal to the area of the big sector minus the area of the small sector. The big sector, how do we find area of big sector? Theta over 360 times pi r squared. Now, what's the radius of the big sector? The radius of the big sector, you realize, if this piece is 2 and this piece is 5, the big sector have a radius of 5. Therefore, it is now theta. Remember, area of sector. Area of a sector is what again? It is theta over 360 times pi r squared. You have to remember that formula. So now it is just going to be area of the big sector, 40 over 360 multiplied by, I don't know why I keep disappearing, multiplied by pi r squared, pi times 7 squared. That's big sector. Minus 40 over 360 times pi r squared. But the radius of the small sector, so the small piece here, the radius of that small piece is what? 5. 5 squared. So in that case now, we just work it out now. You can put everything in the calculator one time. I'm going to cancel the zeros. And I realize this is now 4 over 36 is 1 over 9. So 1 over 9 times 7 square. I think 7 square is 49. So that's 49 over 9 pi minus, this is 1 over 9, but 5 square is 25. So that's 25 over 9 pi. Then when I subtract, 49 minus 25 is 24. So I get 24 over 9 pi. And I put that in my calculator. Now, you may not feel as comfortable adding and subtracting with fractions, but if that's not the case, you can put everything in your calculator one time. You do not need to do what I do. You can just put everything in the calculator one time. So it works out to be 8 over 3 pi. And then now you can just work that out now. 8 over 3 times pi, which is 8.38. That's 8.38 centimeters squared. That's our answer. 8.38 centimeters squared. Nice, that's it. Next question. Okay, so this question now. Go ahead, pause the video and attempt this question. It says, the figure below shows the sector OAB of a circle with radius 9 and an angle 41 degrees. Find the area of the sector OAB and then find the area shaded. Pause the video, attempt this question, have some fun. Alright, let's go. First thing is they told us it's a sector. So you must remember, so for part 1, what do we know? Area of a sector, part 1, area of a sector we know the formula is theta over 360 times pi r squared. Theta is 41. 41 over 360 times pi times the radius being 9 squared. Put that in a calculator for me, please. Don't stress yourself. 41 over 360 multiplied by pi times the radius being 9 squared. No issues so far. This is straightforward. 28.98. Or I'm just going to round it off to 29 centimeters square. Next thing it says, hence find the area shaded. Now, guys, this is so easy. Why is it so easy? Part 2. Find the area of the shaded part. Isn't that just the area of the triangle? See, I have a triangle here. If you find the area of the triangle, right? And then you subtract out the area of the sector. You subtract out this piece. What are you left back with? You're left back with the area shaded. You're left back with in here, so that's also minus now the area of the sector. Then that don't give us the area shaded. So all we need to do is find the area of the triangle first. No problem. Now, it seems like it's going to be difficult, right? But no problem. Now, if this is a circle, right? This side is 9. Then also this side must also be 9. Now, in that case now, right? What do we have? We have two sides. We just did this in a previous video. We have two sides of a triangle. We have 9, 9, and the angle in between it, right? We have two sides and the angle in between it. What do we know? What we do know is we can find the area of that triangle, but however, we need to find the length BC, right? We need to find the length BC. Because what do we notice? We're noticing, well,